Okay, hello everybody. So today I didn't want to leave you just kind of hanging on lesson 13 too. I wanted to help you make sure you can be productive on homework today. So what you're going to need for homework today is you're definitely 100% going to need graph paper. So if you want to get graph paper right now, get your homework paper set up to say lesson 13 too. You guys are doing page 475 to 476. 5 through 12 and 17 through 21, and that is pretty much your goal, is to get that done in class today, and then use any other time you may have possibly to do corrections if you need to go back and finish anything out of 13.1 from yesterday. And if you get all of that done, there's a bookshelf full of activities over against the wall that you can help yourself to. So get paper set up. Get your packet of notes out from yesterday where we did all of your colorful absolute value functions, and I want you to kind of have those side by side. So get everybody to that point and then come back to me if you need to. Okay? All right, so here's the deal. I wanted to kind of have you guys get to the absolute value part of your notes yesterday and maybe even add this at the top of it, because we kind of got through the majority of the notes with every class period, but we didn't get to just really sum it all up at the end here. So when you guys did each page of your notes yesterday, each page did some sort of a different transformation to your graphs. So I kind of want to sum that up. On the front page, those are the ones where if you plugged a number in here right there for H, changing the H moved your graph to the left or to the right. Okay, then the second page, if you changed the K, it moved the graph up or down. And then if you changed the A, that's when it would stretch it and shrink it. Or if you made the A a negative, it's when it would flip it and reflect it over. So when we put that all together, you guys are going to see full equations like this that you guys are going to graph. But I want to show you a couple of pointers within your packet of notes here to kind of help you connect it all together and you actually be able to either write equations or graph them correctly with your homework today. Okay, so here's the deal. What I want you to notice is that there is a trick to not needing to make all these tables. The idea is that you should not be trying to make tables to do these graphs. Okay, when you guys look at every V-shaped absolute value function, they all have a vertex. So here's what I want you to do. Look at these with me real quick. This vertex right here, okay, is at negative 2, 0, 0, 0, and 3, 0. Okay, what I want you to notice is that number in the x, the negative 2, 0, and 3, that x coordinate of your vertex, every time that x coordinate was one of these numbers. Like whenever we had the minus 3, your vertex was at 3, 0. Whenever we had the plus 2, your vertex was at negative 2, 0. So you can tell a lot where the vertex is going to be by if you will look at this number inside of the absolute value sign. It gives you the x of the vertex, but it's always the opposite. How we said minus 3 actually means right and plus 2 means left. So this is a vertex that starts at 3, 0. This is a vertex that is at negative 2, 0. So those are just opposites. Live with it. Okay, well, when you look at the second page of those notes, look at these. Okay, this vertex is at 0, 3, 0, 0, and 0, negative 2. So right there, the 3, the 0, and the negative 2, guys, that is what goes here. The y coordinate was 3. The y coordinate of this vertex was negative 2. Okay, and on this page, the key that we figured out is that the number that was in the A position in front was the slope of the sides. So here is why I wanted to just kind of refresh your memory with that. If you guys will look on page 475, okay, you guys are starting on number 5. And number 5 says, graph each absolute value function. And they give you this, g of x equals the absolute value of x plus 3 minus 1. Okay, so go to your graph paper. We're going to do number 5 right now. Okay, if we were going to do number 5 right now, let me write down the equation with you guys. G of x equals the absolute value of x plus 3 minus 1. Okay, here's the deal. I don't need you to make a table to do that. I need you to use what we just talked about out of your packet. Okay, with this absolute value function, okay, you have a +3 in here, so that tells you that the x coordinate of your vertex, remember how it's opposite, that actually means 3 to the left. The x coordinate of your vertex is -3. The y coordinate, this -1 means 1 down, so the y coordinate is -1. So guys, this is your x coordinate, but it's the opposite, and this is your y coordinate. So I'm telling you that when you graph it, I don't need a table. I need you to know, oh, the point of the v is going to be at -3, -1. And then remember how we talked about slope? See how there's not a number here in front of the absolute value sign, like there's nothing there? So your slope is 1. If there had been another number there, it would change the steepness of the sides. So here is what you should be doing on your graphs today. Okay, now that you know what this should look like, go ahead and draw yourself an x and y axis. And as long as you're counting by ones, I don't need you to really number it. There you go. Okay. You're going to put a vertex at -3, -1, right? And the slope of the sides is going to be 1. So you should go up 1 over 1 in each direction to make the V shape. So this is what I was saying about making connections about what we learned from moving left and down. So like, you know, a plain absolute value of x would start in the middle at 0, 0. But that 3 says move it 3 to the left. That -1 says move it 1 down. And the sides say be a slope of 1. So see if you guys can make that happen working together on that. And you guys can stop and do 6 if you want. And maybe see if you can decide on what you think the vertex should be. Okay, and then when you are ready, we're going to do at least one of the next section. Number 7, they graphed it. You're going to write it. Okay, so when you're ready, let's move on to 7. Okay, for number 7, they say to you, you should write an equation for this. Okay, it's like what I just showed you in reverse. The key is doing the vertex. And I hate that they counted by 2s on all of these graphs, but they did, so we got to live with it. So understand, if the vertex of this is floating in the middle of that square, this is at 5, 1. Is that agreed? That vertex point is at 5, 1, because the grid is counting by 2s. Okay? So the vertex is at 5, 1. And then can you tell, like this goes up from 5, 1 to there's a point right there at 6, 2. So it's going up 1 over 1, up 1 over. The slope is 1. Okay? All right, so here's what I would do. Write this down for me. The vertex, we said, was at 5, 1. And then the slope of the sides is 1. Okay, here's all you got to do. And this is where, if you want to go back to this that I had you write in your notes, you literally fill in the A, the H, and the K based on those 3 things I just had you look at. Okay? So you would write, okay, and I don't care if you write g of x, f of x, it doesn't really matter. Okay? But the slope goes in front. We don't need to put 1. Okay, so you're going to have your absolute value signs, and inside the absolute value signs, it goes x, and it's always the opposite of this, so it's going to be -5. And then that's a +1, so it's a +1. So the slope goes in front of the absolute value, the x-coordinate goes in here, but opposite, and y-coordinate goes here. So that's how you guys are going to write all of those. So that should help you out on like 7 through 10, actually 7 through 12, so that you guys can work through those. Okay, and then you guys are jumping to 17 through 21. So real quick, if you just want to take a look at 17, we can get that going, and then you guys should be able to be very productive the rest of the time. Okay, so on 17, g of x equals 3 times the absolute value of x. Okay, so that's going to be a graphing one. So if you just want to maybe, I don't know where you want to do this on your sheet, but flip it to the back side if you want. But let's get 17 going. G of x equals 3 times the absolute value of x. Okay, so same as I told you when you graphed the very first problem on the whole assignment. Figure out the vertex. See how there's nothing inside of there with the x? That means your x coordinate is 0, and see how there's plus nothing out here? Your y coordinate 0. So this has not been moved to the left or to the right at all. All it's done is had a stretch happen to it. So you're going to start at 0, 0. You just need to make it have a slope of 3 on the side. So it's going to be steep on the sides. That's the only difference. Okay, so let me zoom out a little and draw myself a grid. Let's see. Let's make it kind of tall on the positive side. Okay. So your vertex is at 0, 0, and that 3 stretches it. So you should go up 3, out 1, up 3, out 1. Same on both sides. So you will have a stretched V. Okay, so 18, 19, 20, very, very similar to that. Okay, so work on 17 through 21. Be productive. We will grade this on Tuesday when I see you guys again. And 13.3, good news, no graphing. So this assignment, corrections, missing work, or any of the various activities on the bookshelf. All right, have a good, productive Friday. See you guys Tuesday.